Like you said, my name is Matt Young. This is, I screwed up so you don't have to. Basically, there's nothing fancy or special about me. I'm just a developer that inherited a mess, which I'm sure a lot of us here can relate to. So what I'm doing right now is I'm working in Node.js. We're doing APIs for a front end that is handling professional growth for teachers. Basically, they have a certain amount of continuing education credits they have to get every year, and we kind of assist with that. Couple of things to know about me first. I do have some issues with social anxiety. It's medicated, but I will not be holding still, so I apologize if anyone's trying to track that. So, also, there's that joke that's like, if you're nervous, just picture your audience in their underwear, and all it does is make me more nervous because you guys are all comfortable sitting in your underwear, and it's weird. So to start things off, the company I worked for before Frontline Education was School Improvement Network. They're based out of Midvale and Salt Lake, then they got acquired by Frontline. It's used an older system. It was a Flash Flex front end with Coldfusion on the back end, which, 12, 14 years ago when that was written, that was considered state-of-the-art. It is definitely not state-of-the-art anymore. And one of the big issues we had is we were stuck using outdated technology. Not only were we using Coldfusion, we were using Coldfusion 9, which, 10 came out the next year and we weren't using that. So it made it very, very difficult to innovate. Things that should have been super simple took us a lot of extra work. Just making something that you can handle a JSON request took a surprising amount of work in Coldfusion 9. It had a single point of failure. We had 4 production servers that were all Coldfusion, but as soon as one thing went wrong in one of those servers, it basically knocked the server out. So just a simple unhandled exception ended up knocking out that entire server, which, there goes a quarter of what you can handle. Which was another issue we had is that would happen a lot, and then we'd have a lot of downtime just because of simple one-off requests. So what happened, we had a couple of senior developers at the time that they took the challenge to go and try to make it better. We wanted to make a more advanced system, something that can handle things better. And what they were looking for was technological freedom, first off, because Coldfusion stunk. I know it now, and I'm never going to use it again. So we wanted to be able to do whatever language made sense at the time. We also wanted to have easier development. It took a lot of work to get a server up and running. There was always all these little configuration things that you always forget about with Coldfusion. Admin pages, config files, all sorts of junk. We also wanted to be more agile. We wanted to be able to test things out. That was an issue we had before. When you went to go do a deployment, since everything we had was so fragile, you would deploy, and then you kind of wait. And if something goes wrong, then all of a sudden your system's down, and then you're scrambling. We also wanted to have more quality code. Coldfusion, again, I inherited kind of this. We didn't have a lot of automation testing in place. A lot of it was just hand testing. And again, when you have multiple points of failure, or multiple failures that can break the entire system, that made testing extremely stressful. Also, scaling was a whole nightmare. With Coldfusion, you had to have a license. And then again, with all the setup and everything, it had some challenges. So the solution that they came up with was using microservices, and specifically Node.js. At the time, we were moving a lot of stuff from Flex into more of a standard, JavaScript type front end. And they decided to move the back end there as well. They wanted to have one language that ruled them all. Again, I'm sure we have all heard that. But the big thing they wanted to push for is that we could develop in any language. If we had a microservice, we could theoretically have something running Python or C# or .NET or something. And the request can come in and it can handle it just as it would anything else. It made it so we could develop quicker. Small services we can get spun up and deployed in a matter of minutes as opposed to hours, possibly days before. We were told that the deployment times would be faster and outages would be more resilient. If we had a service that went down, we could just spin up a new version of that service almost instantaneously, and there you go. So what microservices pitched to us at the time, it was a lot like sailing a ship. You've got a crew. That crew does one job, or each person on the crew does a job. They're responsible for that. When you have something like the Coast Guard or the Navy, and it's very well maintained. It works amazingly. That, however, so I was just barely starting development at this time. I moved from QA to development, and all that sounded promising. All of it sounded exciting. And really, what could go wrong? And that's when, stuff went wrong. We didn't get a crew, we got the Muppets. So it was kind of a mess. There were unnecessary interdependencies between services. You'd have an authentication service that everything would have to go through. Every single API call had to go through that authentication service. If that authentication service went down, your entire service went down. We had an over-reliance on assumed information. Like this service, even though it's just handling a user, it needs to know that the authentication object looks like X. And that's not what you're supposed to be doing with microservices. It should be independent. They should be able to be what it is and then just handle their own thing, which caused a lot of replication across a lot of, it replicated business requirements across the services as well. There's a lot of stepping on toes. One development team would make a change. It would bring down that service, or it would change something that, again, it had to know about it further up the stream, and it doesn't know about it. So we spent way too much time developing features that were never needed. These two developers, the senior developers that got us started down this path, both of them eventually left before the project finished. So we ended up having to, they spent almost a year just doing R&D and getting all their ducks in a row, and then to have that leave, all of a sudden, again, held with a mess. And things, they kept making promises that it was going to be smooth, that it was going to be amazing. Like JavaScript with microservices, you can't go wrong, it's a home run, and that is not what we saw. So the basis of this is things that I learned in my experience of picking up this mess. This is the gospel according to Matthew, not to be confused with the gospel of Matthew. So the first things first, microservice design. When we designed our microservices, it's with the idea that each microservice has its own independence. There shouldn't be that dependence on knowing what the other services are doing. It should just be able to do its one thing and then move on. And if the microservice is set up correctly, that could break, and then the rest of the 80% of your application should still be able to run. They should have access to their own databases. This is something that we had an issue with originally, where we were moving from this monolith, this system that you could have access to every database, every table, everything all at once, to all of a sudden users should only have access to this, and content should only be this, or videos should only be this. But we'd still have that tendency of wanting to cross those lanes. So let's say the user can use this database, but groups are really just groups of users, so they should be able to use that database as well. We had to break out of that mindset to really embrace the microservice idea. And everything needed to be Dockerized. This was something that I'd never used Docker beforehand. We, again, just had physical servers with the monolith. And getting everything to the point that it can be used in one location. So your local development is the same as your upstream development. That was extremely useful. It was something that looking back at it now, I can't imagine having to go through this without that. One of the biggest issues we had, though, was with load balancing, scaling, and monitoring. We had dozens of services that were all, or microservices that were all running, many of them 2 to 4 replications of each service. Then combining that all together so you have load balancing and then you're monitoring all that, that was kind of a nightmare, which the solution we had was PM2. PM2 is a process manager that launches your node instances, and it handles all the threads for it. So from their website, PM2 is a daemon process management manager that will help you manage and keep your application online. It's a super cool system. That looks like crap, I'm sorry. So what it does is you just set it up with a simple configuration file that you basically say, hey, I want you to watch these files, any changes that happen in these files, restart the process. If you have any errors, restart the process. I want you to have X number of instances running at the same time. We use 8 on our production environment, so each Docker container can handle 8 simultaneous processes that are all running the application. And then monitoring is all built in. There's a PM2 space monit that brings up that screen right there. Combines all your log files together into one thing. You can see how much memory, how much CPU, how much file it's using. If there's any errors or anything acting funny, it'll throw it out there for you. The other thing that I can't stress enough is to keep it simple. There's that saying, keep it simple, stupid. Stupid's kind of become a bad word with my kids in the house, so something else, keep it fuzzy simple. Like, this is a guy that, thinks that there's a guy living in his finger that tells him to do things. It should be something simple enough that Fozzie the bear can figure out how to do it. One of the acronyms that I found when going through this is YAGNI, which is you ain't gonna need it. We have a tendency to want to develop bigger than what we are. Or we want to make something future-proof, and in the process of making it future-proof, we end up spending a lot of development time on something that will never see the light of day. Or if it does see the light of day, it never gets used. Wow, completely derailed there. All right. Continuing on then, when converting existing components, it's best to start it with the smallest part, or the least complicated to go to the most. The 2 developers that started us down this process, they decided, hey, the user is going to be the thing we convert first. The user was obviously one of, if not the biggest component that we had, which made it an absolute nightmare. Instead of starting with something simple and then moving away from the monolith onto that one simple thing, and then moving on to another simple thing and breaking it apart like that, they decided to go full bore. And now, since all of a sudden the user's over here, everything over here that's expecting the user on the monolith has to now either communicate with that microservice or be broken up itself, in which case we're just so coupling in that microservice to the monolith that it's still just a monolith. It's just a monolith with a satellite. There we go. We shouldn't be trying to prove that we're smarter than everyone else. So don't overdevelop. I know we have a tendency to think that we are smart. I mean, we do a job that many find difficult. But that doesn't necessarily mean that we should be out there trying to make things complicated just for the sake of complication. I'm personally a fan of things being easier and things being simpler. My code tends to be boring as all get out, but you can tell what's going on with it. So the other aspect that really needed to focus on was team structure. So the team should be responsible for one service. That doesn't necessarily mean that multiple teams, or one team can't handle multiple service, but we had a team in the Philippines. So at its height of the microservices, we had 3 local development teams, and I think 4 or 5 teams in the Philippines. So we had 8 development teams. And those 8 development teams could be working on anything, and you didn't know what it was working on. So all of a sudden, your user service isn't working anymore for something that you just developed yesterday, only to find out another team made a change to how the object looks, and now all of a sudden, all your stuff's going to break. It may not be technologically or even economically feasible to have one team work on one service, but at least having that single point of contact makes it so that if there are changes, it's more controlled and it's more intentional, as opposed to, oh, it's just quick and easy, I'll just add that in. Teams should also consist of individuals with different domain responsibilities. So this is like QA with front-end development or back-end development or product management. Once we moved to that structure, it actually made microservices a lot easier to develop. As opposed to making it like the monolith, we're now using building blocks. And those building blocks, we can structure it so we can get you basically what you need. You can start creating your own APIs. GraphQL is something we were looking at before. As long as you're not doing too much business logic, it's something simple. And again, since it's a microservice, it's that one isolated location. You can use whatever technology or theory that you want on that. but it does depend on a cross-domain knowledge. So just a miscellaneous thing here. Private NPM packages are amazing, especially in the especially in the instance that you're replicating business logic between services. We were using RabbitMQ to communicate between services, and so we had our own little utility that we had that was called Lappin. Basically, it was a way that it just wrapped the requests, wrapped the responses, made it sure that everything was routing to where it needed to be. Once we moved Lappin out into its own module, all we had to do was just load in that module and we're good to go. We started doing that with a lot of smaller things. If there were instances that we had to use the same database for multiple microservices, they all handled their own authentication. We had validation in there to make sure the objects going in here are the same as going on here, and it's all because of the private NPM packages that we used. It's something that I have a reliance on, and I can't recommend it enough. Something that, I mean, if you're going to be writing the same 10 lines of code in 5 or 6 different microservices, may as well just make that a package and then just load that in. Any changes that you make are going to be changed all across it. Invest in DevOps, especially DevOps that knows what they're doing with that. Once we got our system so it was auto-building, we had tests executing at every commit. And we were able to handle multi-phase commits. If you're working on a feature, and that feature requires you to make a change to the user, it also makes a change to the group, you'd have to have this like organizational ballet dance that you'd have to make sure that this commit goes in first, but then this one can go in, so then it meets the dependencies required for this, but then this was only a partial commit because you still needed that one to pass. So trying to organize it all together at once took a lot of work that a lot of people smarter than me ended up getting figured out. But auto-building and automatic test running, both of those also solve a lot of those issues with us as well. One last small thing, UUIDs instead of auto-incrementing IDs. It might sound simple, it might sound basic, but it's something that once we moved to that, I can't tell you how many headaches that solved. Especially when an ID, you don't necessarily know what that ID is for. You don't know if it's a license or a group or a video. If you're using a UUID, you don't need to care about it as much because your chance of collision and the chance of using that or replicating that same ID across locations goes down. Also, you kind of need to come up with a, in case of emergency, break glass situation for whenever you go to production. What that's going to be, it's going to, you know your systems better than I do, but go in with that mentality. That is something that we were arguing with those 2 developers for months before they left. That when crap happened, what was the solution? So when it broke, how are we going to come back to it? And instead of them saying, well, it's just not going to break, it's like, well, yeah, it's going to break. Like, it's just a matter of when and what are we going to do for that. So in conclusion, I want to thank you guys for listening. This is my first time doing a presentation. Obviously, I have some notes I can take back to myself. But I encourage you to look into microservices. If it's something that you guys are looking at, it's something that you need to embrace, though. Don't just go into it, just dip your toe into it, just jump full in, because otherwise you're just going to end up making, again, a bigger monolith. So, thank you.
Thank you, Matt.